Hi, ladies and gentlemen. So we have our last activity of Chapter 5 today. It's for the 5.3 lesson, Day 2. Can you get a pair of aces or a pair of kings? So the rules of the game that we were going to simulate, had we been together, were 5 cards total, 2 aces and 3 kings. The player chooses their first card and records the result, then chooses their second card without replacement and records the result. The player wins if they get a pair of aces or a pair of kings. So we were going to simulate this to look at how close we could get to the theoretical probability with actual data. But since we're not together, I'm actually going to skip over that, and we're just going to look at the tree diagram that could be created in order to then actually, try and identify our theoretical probability here. So, here we go. So what we want to think about with this ace game, the probability that the first card is an ace. So we have a total of 5 cards. So the probability that the first card is an ace is 2 out of 5. The probability that the first card is a king would be 3 out of 5 because we have 3 kings in our deck of cards. From there, we have to remember that each time we pick a card out, we have one less card then in our stack because we're not putting it back. So if the first card is an ace, what's the probability of then the second card being an ace as well? So if we think about it, we had 4 cards. I pulled one out though, so now I only have 4 cards remaining. So all of these denominators in this second tier of this tree diagram, we're all going to have a denominator of 4 because I only have 4 cards. If we look at the first part of this tree, if I already pulled one of my aces, then I only have 1 left in my stack. So the probability that the first card is an ace and the probability that the second card is an ace on that second tier there is going to be 1/4. Now let's say the first card I pull is an ace, right? So now this is following this part of the tree I've highlighted in purple. The first card I pull is an ace. I have 4 cards left. What's the probability that the second card is a king? Well, out of those 4 cards, 3 of them are kings. Because I didn't pull any of the kings yet in this first branch, so I still have 3 kings. Now let's move along to the second branch. The probability that the first card is a king is 3 out of 5. After pulling a king out of my deck of cards, leaving me with 4 cards now, what's the probability that the second card is an ace? Well, out of those 4 cards, I still have 2 aces because in my first round of picking a card, I didn't pick an ace, I picked a king, so I still had the 2 aces remaining. Looking at this last branch, the first card I pull is a king, then what's the probability the second card is also a king? Well, I have 3 kings in total. I pulled one out, so I still have 2 remaining. So hopefully filling in these branches so far has not been too confusing for you, but if you feel like you're getting lost in this theory, if you have a set of cards at home, it would be great for you to actually make this deck that we're talking about and really visually see everything that's going on, because I think that can really help illustrate this. Now let's get into these rectangled boxes that are on the far right side of this paper. For the first one, it says, what's the probability the first is an ace and the second is an ace? When we have this and probability, what we're doing is we're going to end up multiplying our branches together. So the probability that the first is an ace is 2/5. The probability that the second is an ace is 1/4. So we're going to multiply those 2 fractions together to give us 2 out of 20, or in other words, 0.10. Using that process now with our next branch, 2/5 times 3/4 would be 6 out of 20, which is 0.30. Looking at the next one, probability the first is a king and the second is an ace. That would be 3/5 times 2/4, which is 6 out of 20, or in other words, 0.30. And then the last one, probability the first is a king and the second is a king, would be 6 out of 20, which is 0.30. Now, if we were to add all of these probabilities up, they would give us 1. 0.3 plus 0.3 plus 0.3 plus 0.1 is 1. And they should always add to give you 1. If they don't, you're missing your probability somewhere or some math went wrong because it always is a 100% chance of something happening. All right, so now it says find the theoretical probability of winning the game. We'll think about how did we define winning for this setup? Winning is getting a pair of kings or a pair of aces. Well, that happens with this first one if the first is an ace and the second, and with this last one if the first is a king and the second. So to find the probability of winning, we'd be looking at finding the probability of getting 2 aces or 2 kings. Or probability means we are going to be adding those two probabilities together. So 0.10 plus 0.30 gives us a probability of 0.40. Last one is a conditional probability. So I'm going to move this up here. There we go. It says, what is the probability that the first card was a king, given that the person won the game? This is a conditional probability because we're given a set of circumstances that needs to be taken into consideration when answering this probability statement. The way we set up these conditional probabilities is we're going to say probability that the first is a king, and then we use this solid bar to represent the word given someone won the game. So we know that they're going to win. So the total probability of someone winning the game we found in question 4, which is 40%. Out of the 40% of those that win the game, what's the probability that that person's first card was a king? Well, the first card being a king happens, let's see here. And then winning, yes, okay. So that is 0.30. The 0.30 is coming from out of someone that is 1, what's the probability that their first card was a king? That's the 0.30 number. But because we're given the circumstance that someone won, we're writing it out of 0.4 because that's the total sample space of the probability of someone winning. And dividing those gives you 0.75. So let me re-explain conditional probability a little bit to you. Conditional probability gives you a certain circumstance where it kind of narrows your sample size. So you're not looking at everything, you're just looking at whatever given condition the problem presented to you with. So here they told us, given the person won the game. So that says my denominator, which is my total sample space, is only those that have won, which is a 40% chance of happening. My numerator is out of those that have won, the probability of someone winning with a king was 30%. So conditional probability sometimes can be challenging because you have this condition that you have to be thinking about. So make sure that you are looking at the back side of this worksheet to get just some additional practice with this and with the conditional probability, as well as in your notes. There are a lot of good example problems with conditional probability that you're going to want to make sure that you do. All right, that is it for the activity for the Lesson 5 3 Day 2. Have a great day. Let me know what questions you have.